Every day, artificial intelligence is touching our lives in ways we often don't even realize. From the personalized recommendations on your streaming service, to the precision of your GPS navigation, to the way your phone unlocks with your face, AI is no longer a distant sci-fi concept. It's here, it's evolving rapidly, and it's becoming an invisible hand guiding many of our digital interactions. But what is this intelligence? Is it truly thinking? How does it learn? And why is it considered the next great technological wave, poised to reshape our future? In this episode, we'll demystify artificial intelligence, breaking down its core components, especially machine learning and neural networks, to give you the fundamental understanding you need. In our last episode, we explored the concept of technological waves, those profound shifts that reshape human civilization. From the agricultural revolution to the information age, we identified artificial intelligence as one of the most significant emerging waves of our time. Its potential impact spans every industry, every aspect of our lives, from healthcare to entertainment, transportation to scientific discovery. But to truly understand where AI is going, we first need to grasp its basic principles. This isn't about complex algorithms or coding. It's about understanding the core ideas behind how machines can appear to think, learn, and even create. Let's begin by defining what we mean by artificial intelligence. At its simplest, artificial intelligence (AI) refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. It's about enabling computers to perform tasks that typically require human cognition, such as problem solving, understanding language, recognizing patterns, and making decisions. It's important to distinguish between two main types of AI. First, and what we primarily experience today, is narrow AI or weak AI. This type of AI is designed and trained for a specific task. Think of a chess-playing AI that can beat a grandmother, but can't hold a conversation or compose a symphony. Your smartphone's voice assistant, a spam filter, or a recommendation engine. These are all examples of narrow AI excelling at a singular function. The second type, largely still theoretical, is general AI or strong AI. This would be a machine with human-level cognitive abilities, capable of understanding, learning, and applying intelligence to any intellectual task that a human can. Imagine an AI that could learn a new language, then compose a novel, then solve a complex scientific problem, all without being specifically programmed for each. While much research is dedicated to this, it remains a significant future challenge. For now, our focus is on understanding the powerful capabilities of narrow AI and the fundamental techniques that make it possible. So how do machines gain these intelligent capabilities without being explicitly programmed for every single scenario? The answer lies in machine learning. Machine learning is a subset of AI that gives computers the ability to learn from data without being explicitly programmed. Instead of a human programmer writing a rule for every possible outcome, the machine learns the rules itself by analyzing vast amounts of data. Think of it like this. If you wanted to teach a computer to identify a cat in a picture, you could try to program in every single feature. If it has pointy ears and whiskers and a tail and says meow single quotes double quotes, but that's impossible. What if the cat is sleeping or facing away? With machine learning, you instead show the computer millions of pictures, some with cats, some without, all labeled. The algorithm then analyzes these images, identifies patterns and relationships that it deems important, and creates a model that can then predict whether a new unseen picture contains a cat. The more data it sees, the better it gets. There are three main types of machine learning. Number 1, supervised learning. This is the cat example. The machine learns from labeled data input and correct output are provided. It's like a student learning with flashcards. Number 2, unsupervised learning. Here, the machine is given unlabeled data and told to find patterns or structures within it. Imagine grouping similar customers together based on their purchasing habits, without being told what groups to look for. Reinforcement learning. This is like training a dog with rewards. The AI learns by trial and error, performing actions in an environment and receiving rewards or penalties based on its success. This is often used for training AI in games or for robotic control. Machine learning has truly revolutionized what AI can do by allowing systems to adapt and improve over time without constant human intervention. While machine learning encompasses many techniques, one type has emerged as particularly powerful and is often associated with the most impressive AI breakthroughs: neural networks. Inspired by the structure and function of the human brain, artificial neural networks are composed of interconnected nodes or neurons arranged in layers. Input layer: this is where the data enters, perhaps the individual pixels of an image or words from a sentence. Hidden layers: these are where the magic happens. Each node in a hidden layer receives input from the previous layer, performs a calculation, and passes its output to the next layer. These layers extract increasingly complex features and patterns from the data. The more hidden layers, the deeper the network, hence the term deep learning. Output layer: this layer produces the final result. For instance, identifying the object in an image, translating a sentence, or predicting a stock price. Think of it like a chain of detectives. Each detective node focuses on a small piece of evidence. They process their information and pass it to the next detective, who combines it with other pieces. By the time it reaches the final detective output layer, a complex conclusion has been reached. During the training phase, the network adjusts the strength of the connections between its nodes based on the difference between its predictions and the correct answers if it's supervised learning. This process, repeated millions or billions of times with vast datasets, allows the network to learn and refine its ability to recognize patterns, make predictions, or generate outputs with incredible accuracy. This is how a neural network can learn to distinguish between a cat and a dog, translate languages, or even generate realistic human faces. So when we talk about artificial intelligence, we are often talking about machine learning and very frequently about the astonishing capabilities of neural networks. These technologies are not just theoretical. They are already transforming industries and creating new possibilities. They allow us to analyze vast amounts of data, automate complex tasks, discover new patterns, and even augment human creativity. Understanding the basics of how AI learns through data, algorithms, and brain-inspired networks is no longer just for tech experts. It's becoming a fundamental part of being an informed individual in our rapidly evolving world. It empowers you to understand the headlines, evaluate the opportunities, and even contribute to the discussions about how these powerful tools should be developed and used responsibly. What's the most surprising use of AI you've encountered? Share your thoughts in the comments below. This was just the groundwork for understanding artificial intelligence. In our next episode of Future Forward, we'll explore L1.3, the Internet of Things IoT and connected devices, and how AI is woven into the fabric of our increasingly smart environments. To continue building your knowledge of these transformative technologies, subscribe to the Knowledge Compass and hit the notification bell. Share this video with anyone eager to grasp the basics of AI. Thank family and friends for thinking forward with us.